and some of the properties we discussed last time, and let us now move ahead. Next property is time convolution property. So as we did in the last semester also, time convolution means if two signals in time domains are convolving with each other. That means suppose x1 n is one signal, discrete time signal, and it has to convolve with another signal which is x2 n. Both of them are discrete and non-periodic. Okay, and if we take Fourier transform of it, okay, then what happens to the frequency domain signal? The frequency domain signals are just multiply with each other. If x1 omega is DTFT for this, and x2 omega is DTFT for x2n, then both of them will multiply. It means that when the two signals convolve in the time domain, their DTFT just multiply in the frequency domain. It is a mathematical thing, so we can have a proof for that. For example, if I write the left hand side, I can write left hand side as per definition. What will be this? This will be the Fourier transform of convolution of this, and we know what is convolution sum. Convolution sum is k changing minus infinity to infinity x1k into x2 n minus k. Okay, this is what the convolution is, and we have to take Fourier transform of it, DTFT of it. So as per definition of DTFT, we know that it can be written as, let us suppose it can be written as some n changing so if n is changing minus infinity to infinity, and this thing, this is the definition of into, this is the function, into e raised to power minus j omega n. Okay, this sum is on n and this sum is on k. Okay, so these are two sums, and if we interchange the order of the sum, it means इसमें पहले n में हो रहा है, पहले k में हो रहा है समेशन, इनर समेशन k में है, then we are performing on n. अगर हम इनका इंटरचेंज कर दें, यानी कि पहले n में करें फिर k में करें, so it will remain the same. Let us see what will happen then. So the left hand side can be rewritten as summation k changing minus infinity to infinity x1k because for n summation x1k will be constant, so it can be taken outside. Then summation n changing minus infinity to infinity x n minus k e raised to power minus j omega n. Okay, if we put n minus k as another dummy variable, let us say p, then what will happen? Then this thing will change. This thing will change to summation k changing minus infinity to infinity, and x1k, this will come here, x1k and because we have changed n to p, so it will be minus p changing from infinity to infinity x2, sorry यहाँ पे x2 है, x2p e raised to power minus j ओमेगा p, और इसमें एक k की टर्म भी आएगी, उसको हम यहाँ लिख सकते हैं e raised to power minus j k ओमेगा. ठीक है, ये वाली टर्म, क्योंकि यहाँ पे जब ये सब्स्टिट्यूट करेंगे इसमें n की वैल्यू रखेंगे इसमें, तो ये p और k यहाँ आ जाएगा, बिकॉज इट्स समेशन इज परफॉर्म्ड ऑन p and this summation is performed on k. So as per definition of DTFT, these are multiplication of these two functions. It means this thing will be equal to the right hand side, okay, because this is x1 omega and this is x2 omega. This summation is x2 omega, this summation is x1 omega. So this is how we can prove that the modulation convolution property, that if the two signals are convolving in the time domain, they are simply multiplying in the frequency domain. Okay. Similarly, we can prove for the another property. If frequency domain में signal convolve करो, फ्रीक्वेंसी डोमेन में सिग्नल कन्वर्ट कर रहा हो, तो क्या होता है? इट मीन्स दैट कि x1 ओमेगा इज कन्वॉल्विंग विद x2 ओमेगा इन द फ्रीक्वेंसी डोमेन. ओके, देन व्हाट हैपेंस? Then if we take inverse Fourier transform of it, then their time domain signals just multiply in the time axis n. Okay, this is frequency convolution. Its proof is also obvious. So if we take left hand side, so as per definition of this thing, convolution क्या होगा? Convolution होगा दो सिग्नल्स का 1/2 pi minus pi to pi x1 theta minus into x2, sorry, capital x2 omega minus theta, where theta is any dummy variable. We are integrating with respect to theta, so that overall the function is for omega. Okay, this is the convolution of two periodic functions, because x1 omega and x2 omega are periodic functions of 2 pi duration. ये हमने लास्ट टाइम किया था कि जो DTFT होते हैं, they are periodic in nature. So this is periodic convolution of two signals. This is periodic convolution of two signals. Okay, and अगर हम right hand side देखें, what will be the right hand side? Right hand side is just the multiplication of these two things, यानी कि summation. अगर हम इसका फोरियर ट्रांसफॉर्म लें, सपोज हम ऐसा करते हैं, इसको फोरियर ट्रांसफॉर्म लेते हैं, फोरियर ट्रांसफॉर्म ऑफ इन दोनों के मल्टीप्लिकेशन का क्या फोरियर ट्रांसफॉर्म होगा, x2 और x1, इन दोनों के मल्टीप्लिकेशन का क्या हुआ, समेशन n चेंजिंग माइनस इन्फिनिटी टू इन्फिनिटी 1/2 pi minus pi to pi x1 theta e raised to power j omega n d theta and e raised to power minus j omega n into x2. Okay, this will be the Fourier transform of multiplication. यानी x1 का हमने definition लिख दिया, x1n will be this. Okay, x1n will be this, and then multiplication, then इसका Fourier transform. Okay, x2n के सबसे पहले हमने x1n, ये जो चीज है, ये वाली x1n, ये x1n है, और ये जो होगी, ये डेफिनेशन ऑफ फोरियर ट्रांसफॉर्म होगी, ये डेफिनेशन ऑफ फोरियर ट्रांसफॉर्म होगी इसकी, ठीक है। और ये जो है, ये वाली टर्म एज इट इज आने देती। सो दिस इज हाउ दिस एक्सप्रेशन इज रिटन। ओके, इंटीग्रेशन, इफ वी चेंज द ऑर्डर ऑफ इंटीग्रेशन, इसमें दो चीज हो रही है, समेशन और इंटीग्रेशन। अगर हम इसका ऑर्डर चेंज कर देंगे, यानी समेशन पहले ले लें, समेशन बाद में ले लें और इंटीग्रेशन पहले ले लें, तो हमारे को हम इस एक्सप्रेशन को ऐसे देख सकते हैं, 1/2 पाई माइनस पाई टू पाई x1 थीटा and then summation n changing minus infinity to infinity x2n e raised to power minus j omega minus theta and d theta. Okay, इसको ऐसे लिख सकते हैं. Now what is this sum? What is this? This is the DTFT for x2 omega, but here omega की जगह क्या लिखा है? As per definition यहाँ पे लिखा है omega minus theta. So we can write it as 1/2 pi minus pi to pi x1 theta, and this will be x2 omega minus theta, क्योंकि ये फोरियर ट्रांसफॉर्म है x2 का, बट यहाँ पे ओमेगा की जगह क्या लिखा है? ओमेगा माइनस थीटा. सो वी हैव टू रिप्लेस इट बाय ओमेगा माइनस थीटा एंड डी थीटा. एंड दिस इज व्हाट इज द लेफ्ट हैंड साइड. लेफ्ट हैंड साइड यही है. So left hand side is equal to right hand side. Hence it is proven that two signals convolve